Oh, g'day champions, we've got a Randall Ninja here. It's a signature model from Michael Amott, the long-haired ranger from bands such as Arch Enemy and Spiritual Beggars, amongst others. So it's a high gain machine. It's a friggin' 400 watt MOSFET output stage, as witnessed by that monster heatsink there, and the friggin' huge transformer. Have a go at it. You can tell by the text that it's aiming at the metalhead market. And it's got a valve and solid state front end, and it literally says SS overdrive. That's not a Nazi reference, that's solid state. We'll have a look at the schematic and look at how they've structured the thing. So I just had a look at my books. This one was in about 2 years ago. It had a failed solid state relay and just needed a general service. There was scratchy pots and whatnot. And of course the one that had failed was on the board underneath it as the valves mounted on it. So all of that had to come out. I think there was a dodgy valve as well in the front end. So the biggest challenge with this one was the construction. So you got your MOSFET board down here. I don't know if you can see down there, but all the MOSFETs are bolted to the chassis underneath the other boards, and you can't get to the screws. And there's 2 rows of them. There's one on each side of the board. So she's a monster. You can see the big emitter resistors. Oh, sorry, source resistors there. I keep saying emitter resistor like I'm talking about a bipolar output stage. Power supply down this end with big honking caps, and that is the source of our issues. So we love to joke about, you know, manufacturers splooging in their amps with shit tons of silicon, but in this case I haven't used any, and that's the source of the problem. I'll show you why. It's interesting that they've given the minimum load impedance there of 2 ohms. However, the 400 watt which it's rated at is into 4 ohms. I don't think I'd be trusting it's pretty rare that you can trust an amplifier with 2 ohms unless it's specifically designed for it. Be it, you know, a valve amplifier with a transformer like in a basement, or a super heavy duty, seriously over-engineered PA amp. 2 ohms is like nothing. That's like almost like a wire, right? It's like a crowbar probably has 2 ohms. 2 ohms is incredibly brutal on the output stage, and it would need to be a unit with a lot of paralleled output devices to be able to handle that kind of load. Right, so this one was originally 120 volt with 8 amp fuse. It's been converted just by changing that fuse holder over to the 240 volt position, and the fuse has been changed to 4 amps because the same amount of power, twice the voltage, half the current. And I have checked that. I can't remember if I did that last time. It wasn't on the invoice. I may have just thrown that in as a freebie because I think he bought this and then brought it straight here from memory about 2 years ago. It feels like yesterday. Now this is a nice touch here. It's good to see. You've got a big heavy bracket. It's a pretty heavy steel chassis, but they've also chucked like a good 2mm thick oversized washer there just to spread the load out, so you don't get distortion with that massive heavy transformer rocking around. So let's fire this thing up and we'll see what it does. I know what it does, but I'll show you what it does. Alright champions, she's just in standby and already moving this one around. You can see the illumination fluctuating around the front there. That one's really floppy. So the switching isn't working. So that means one of the low voltage rails has likely dropped out as well. And there's a horrible buzzing there when I bring the master up. And that buzzing goes away when I move that cap. So that's the filtering dropping out in and out for probably, considering it's a 25 volt cap, 6800 microfarad. We'll have a look at the schematic to figure out what that is, but it could be a heated DC supply. Could be, considering there's only one of them, I'm guessing that's what it is. But it could be another low voltage rail. But we'll have a look at the schematic and go from there. Alright champions, so here's the power supply. Got our various rails here, plus minus 70 volts, unregulated for the MOSFET output stage, plus 375 for the valve plate supplies. Various other stuff here, which we won't worry about right now, plus minus 15 volt for the op amp rails. But the one that failed is this one here. So that feeds via that connector to pin 1 and 4, the unregulated DC. That gets regulated via 2 7, 8, 12, so that's a positive 12 volt regulator, 1 amp. 2 of them, they feed back down here via some filtering to pin 3 and 6. Pin 3 and 6 come down here, 6 goes off to other stuff, relay control for the output, probably the speaker relay. Pin 6 goes up to these various connectors here. Pin 3 also goes up to some other connectors. So you got LED SS, which is a solid state preamp tube preamp, and rear PCB. So the LED one's just the pretty light up the cabinet LEDs. Current limiter there, and then 8 LEDs to add some bling to the cabinet. The SS Pre, that's taken 12 volt regulated input, and then that's regulating down to 5 volts. Then that 5 volt rail is used to power the relays in that area. Sorry everyone, I've got to try not to zoom in and out as quickly as I always do. I'm looking for what I'm looking for. I zoom in, I find it, I zoom back out. Plus 5 volt rail there. You got a current limiter resistor there. You've got your solid state relays there, and you're also using conventional relays here with the 5 volt rail switched by that transistor, and more of that business up here. And 12 volt comes into the V2 rear. Again, regulated to 5 volts, the 7805, and then that's used for the logic circuitry for the foot switching and whatever, channel switching, and the AT mega supply. So there's a look at the brain box. It is nice having very clear schematics like this, but the problem is you've got about, 15 pages to go through, and you've got to flick back and forth. But with a complex circuit, that's kind of the only way to do it, unless you've got like an A2 printer or A0 printer or something. And again, here you got on the tube, well, it says tube PA preamp. That's confusing because generally PA means the output stage. But tube board here, you got 12 volt coming in here. Now that shows a different amount of pins on this header. On the supply board, it's a 2-pin header, but they've got looms made up where one header with multiple pins branches off to 2 or 3 other headers on various boards. So that can get a bit confusing if you're looking for a direct 1-to-1 pin count from connector to connector. It's not the way it's constructed. So again, that goes down through a 7805. Quite a few regulators on this amp. And you got the solid state relays there being switched by transistors in this case, doing various bits and pieces. So there you go. So now that I'm holding that cap in place with my little probe, the channel switching's come back, so that's promising because see, it's 3-way switching with one button. That gives away the fact that it's microcontroller controlled. And that means the little brain box is functioning as designed, so that's a relief. Said brain box is down there. It's an Atmel AT Mega microcontroller, and that also has MIDI capability as well for, I guess, channel switching, probably solely channel switching, but we'll look into it. So essentially, and no hard feelings towards Bruce, the circuit is very well implemented. However, it's the construction techniques that let it down in this case, which I believe was out of Bruce's control. Just like on the Egnator amps, fantastic sounding, fantastic circuit, but when they started cutting corners at the factory, that's when the problems started arising. So what do we got to do to get this board? Quite a bit. I can either remove like literally everything, every board, maybe with the exception of that front panel one there, to access the screws to unbolt every MOSFET because they're mounted underneath the boards, so I can't get a screwdriver through a board. Well, you can, but it won't work afterwards. So what we might do is see if we can desolder every MOSFET, which can be difficult because they're attached to a heatsink. So they draw away the heat from the soldering iron very quickly, and can make it hard, particularly with lead-free solder, to remove the solder effectively from the side that you can't access. But we still need to undo a lot of cables here and get them out of the way so we can swing stuff out of the way, hopefully not disconnect absolutely everything, although every time I think that, that's what we end up doing, so maybe we'll just start by doing that. So the construction of this thing could have been different, but given probably the price point and the sort of traditional structure of the amplifier head, this is probably the only way they could sort of do it cost effectively. But as a result, like even if you needed to change one of those MOSFETs, you pretty much got to excavate the whole amp and turn it into a 3 or 4 hour job, including testing and servicing, of course. But a lot of this stuff, when you're disassembling and reassembling, a lot of the times just note taking and then going back and referencing your notes when you're reassembling it, just to make sure, because sometimes the schematics can't be trusted or don't go into enough detail. And if you're just relying on the documentation, you could end up screwing yourself later massively hour-wise and have to actually reverse engineer the thing to figure out how it goes back together properly anyway. So I'll dig into it, and I'll see you in your time 3 seconds, in my time 3 hours. Oh, champions. Well, that was fun. We've got most of the central nervous system removed. It's making me nervous. What about you? We managed to leave the MOSFETs in place down there to remove that thermal breaker as well. There's the other quad. So luckily we don't have to get nappy rash cream all over your hands. So just having a look at the bottom of this PCB, they haven't cleaned a lot of the flux residue off. That's the white haziness to it. And interestingly, they've just put a blob of feels like hot melt glue, but I think it's that high temp stuff. Doesn't feel like silicon, just to retain the wires where they've gone, it's too hard to lay that one out, let's just throw some wires at it. To me, that's admitting defeat. But I've just got PTSD from designing a circuit board recently where there was like 1 square inch too small to fit all the stuff how I wanted it. But anyway, so you can see there the MOSFET pads are actually pretty chunky and big and through-hole plated, and they're all intact still, no damage there. If this was like a Mesa Boogie style board with the tiny little pads, they would have been probably ripped out in the process of removing it. So those big chunky traces there, follow them up here and they go to the power rails. One side that side, one side the other, plus minus. And then in the middle, that big chunky trace in the middle there goes to the relay, and that's the speaker output. So we'll inspect all these solder connections. They all look good, including the one I was sus on. So those solder connections still look good for that cap that was rocking around. So I think we've got a fractured lead, which is not great, but we'll replace the cap. Hopefully I've got one of them in stock. Sometimes I don't have the monstrous, massive capacitance value ones in stock in every voltage, but whenever I need one, I usually order 2. Whenever I need 5, I'll order 10, that kind of deal. You don't want to stock electrolytic caps for too long. Like, you can't have them for like 20 years and use them. So I try to keep my stock of weird values pretty low, but sometimes I'll get an extra one if they're not too expensive, just so I can do repairs like this and get them out the door instead of having to wait until I got enough to order with free shipping and then order and wait 2 weeks. And it sucks living in Australia for that. You guys in the States don't know how good you've got it over here. Wait times are massive for everything, and well, look where we are. We're in the middle of nowhere. Yeah, so as soon as I desoldered it, the lead for that cap just came out. It looks like it's just a radial cap, not a snap-in, so that might be another issue. It might be a hole designed for a snap-in and they've just put a radial in there, but either way, there should have been some attempt to shock absorb that thing, especially a 400 watt amp. And these guys all down-tune, they're all genty boys, so they're down-tuned like crazy. It means it's practically a bass amp and rattles around as such. Suscon. Nothing sus. Alright, so what I was worried was leakage on the bottom of the cap. You can see the fractured lead there. Was actually an attempt to glue it to the board, but that hasn't worked. What you really want to do is, you've got a little forest of caps here. You can take advantage of leverage and, like, you know, mechanical advantage and whatever. Put a dab of silicone up the top, and they all sort of shock absorb off each other, and that becomes like one little group of caps there, like almost one continuous sort of structure between them, and they're in a perfect position to do that. Sometimes they're a little bit further away and it's a bit of a pain in the ass, like one's like by themselves and whatever, but this is a perfect situation where a bit of dab of silicone either between or up the top, and like I say, we all laugh at manufacturers like Car that empty a fucking half a cylinder of silicone into their amps and expect people to work on them, but a little bit in the right places goes a long way. Alright, champions. 3 months ago, Brad was working on a hi-fi, wasn't he? He ordered some 6800 microfarad 25 volt Nichicons, 105 degree rated. Good on you 3 months ago, Brad. So I'll get this new one in. We might remove the other ones too, just to have a look at their leads, make sure, I think they'd be the snap-in type, nice and heavy duty. The leads on that little one down there are just radial, so just wire as per the new one there. But large caps like that tend to be only available, at least these days, in snap-on, which have a larger cross-section to the lead, which are much less likely to snap. So we'll do what we can to mitigate any damage there in the future, and then we'll get this whole mess back together again and give it a bit of a test. Alright, so everything's repopulated. I'll just give the bottom a quick scrub, because I'm a bit OCD like that. I can feel the sticky shit coming off it, so I know there's quite a bit of flux residue on there at the moment, and I don't know, I just like cleaning that stuff off. Call me crazy. So to do this and for all cleaning here, you can use a flux cleaner. which is specifically formulated for soldering flux, or you can use the more generic, what I have here, isopropyl, but you need the technical grade. You can't use the hardware store stuff, which is meant for cleaning windows and whatnot. You need the stuff that's 99.9999997 or something % pure. Isopropyl, or isopropanol, I think some people call it, but I believe that's incorrect. Isopropyl is hygroscopic, so if you leave the bottle open, it will absorb moisture from the atmosphere as well, but you're talking a couple of %, not like the stuff that's actually intentionally diluted that you get from the hardware store or the supermarket. So I guess that's why they never say 100% isopropyl. It's always 99.997, because they can never get that last little bit of water from the atmosphere out of it, and it starts reabsorbing it as soon as you open the bottle. Anyway, Brad's useless tips for the day. That's what you come here for, isn't it, champions? So just putting this thing back together, and when I took it apart, champions, any chance you can get to lay yourself some breadcrumbs on how to get something back together, do it. Multiple ways, photos, you name it, anything, diagrams, all 3, all 4, whatever. Anything. It's better to have too much information when you're trying to put it back together and get to pick and choose rather than not enough. So here, these connectors, if you've got a tiny little felt tip permanent marker, or Sharpie as you guys call them, even though some of them aren't really sharp. No product placement there. I don't get money from Sharpie, although I wish I could. But the little fine tip ones, ultra fine point, they're great for writing on these little box connectors. I forget the official name for them. I'm sure someone will enlighten me in the comments. But you can get, so that connector there is CN7B. But, you know, CN just means connector, so just write the pertinent information 7B there. And helps you efficiently put it back together. Alrighty, champions, we've got the board back in. All the MOSFET leads have aligned with a little bit of difficulty, but nothing too hectic. Way better than if we unbolted them all and had to deal with the heat transfer compound. Cleaning that up, and it inevitably gets everywhere, like you find it on the back of your head inexplicably. You find it on your pillow, you find it on your car headrest. As soon as you look at it, it's all over your body. So yeah, we didn't have to deal with that stuff. We'll just resolder those leads and start reconnecting everything. Now down here, get your immature splooge jokes out. Go on. Alright, so it doesn't look the prettiest, but that will do the job. It will shock absorb essentially and keep all of them together in one big group, so there won't be as much stress and won't be any vibration. That failure was not caused by like physical stress to the solder joint. It was caused by constant vibration, metal fatigue. That solder joint was fine, there was nothing wrong with it. It was the break above the board from constant vibration. Before I siliconed them, I actually got all solder off the connections and seated them properly. Those caps weren't seated hard against the board. There was like a 1mm gap, so they were rocking back and forth, and that's not good either. So before I even applied the silicone, I seated them properly, and there was barely any movement then, and the silicone will just make sure there's no resonances or anything weird. Normally I'd like to get my smaller nozzle and just put like a really neat bead up the vertical edge where they meet at each capacitor, but I couldn't find the friggin' thing, and I've got to get some work out the door. So it's functionally the same, but it is tweaking my OCD a little bit, not being as pretty as it should be. But hey, she ain't the prettiest guts in this amp anyway, eh? Kind of spaghetti junction. So I'm reattaching the loom. I numbered some of the connectors when I took it apart to make life easier. Alright, champions, I just had it on the dummy load up to full power for a brief moment, and it is indeed putting out 420 watts RMS into 4 ohms. Beast! And I've just had it under test for about an hour at about 1/3 power, which is the biggest sort of hardship test for a Class AB solid state amplifier. That's when they're least efficient, generate the most heat, despite the common misconception that they're getting worked hardest at full power. They actually get worked the hardest thermally at 1/3 of the power. That's when they're least efficient. So she's all hunky-dory. Let's get it flipped over and back in the cabinet, and then we'll do a couple of sound samples, just some quick genty stuff, you know, thrashy boy riffs. I'll tell you what, this thing's got to be in the running for the coolest grill I've ever seen. Seriously heavy duty, looks like 3mm by 20 something mil 3 by 20 mil aluminium that's been powder coated, but it's got these aluminium posts going through, like square section, but then to lock in each piece they've like swaged or compressed or whatever the section in between to squash the section that's held captive by the flat bar. And there's no rattles or anything, and it looks ultra cool, and it's really good for airflow, so...
There you go, champions. I hope that wasn't too cringy. I chucked in a Maxon phase tone there, which I got for sale in my e-store. Nice little tasteful take on the MXR. I can't get MXR here. I'm too close to the MXR dealer, so apparently like 5-10 kilometers is too close. But anyway, Maxon are great, made in Japan. I put it in the loop, in a parallel loop, so I could change the amount of mix, and that made it not the complete wet signal. You can mix in the amount of wet and dry. Now, I've heard that quite a bit in the rhythm tone of Spiritual Beggar, so I thought it would be cool to try that on his signature amp. So anyway, I hope you enjoyed this quickie. It wasn't too complex, it was just a bit time consuming. Kind of therapeutic, to be honest. it's nice to know exactly what you've got to do and just do it, even if it does take a bit of time. It's the real head scratches where you just nothing makes sense that get to you a little bit mentally. But jobs like this, they're good for the soul. So that should be sweet now. We've removed the biggest weakness being those large caps. I think it sounds pretty good. If anything, a little bit dark. You can see I've dialed in a little bit on the EQ there. But for an all-round metal, very hard rock style amp, and passable clean tones, a little bit honky, but you often get that with metal amps. I think it sounds pretty good. And the build quality, it is what it is. It's a lot of features to fit in an amp this size, and the 400 watts is just ridiculous. But hey, you know, you build it, they will come. So anyway, thanks for joining us, champions. Like and subscribe, or I'll bring a generator and play this in your front yard at 4 AM every day. All right? See you at the next one.